Lightning, a sudden, violent release of electrical energy in the atmosphere. It illuminates the sky with a jagged, brilliant flash, cutting through the darkness with an almost otherworldly brilliance. It is a force of nature that inspires awe and, at times, a healthy dose of fear. The sheer power and unpredictability of lightning have fascinated and terrified humans for millennia. For centuries, humans could only observe this phenomenon from the ground, safely below the storm clouds. We watched in wonder as bolts of lightning danced across the sky, often accompanied by the deep rumble of thunder. But with the advent of air travel, we've taken to the skies, sharing airspace with these electrical giants. The invention of the airplane has allowed us to experience the atmosphere in ways our ancestors could only dream of. Imagine a metal tube, packed with people and sophisticated electronics, hurtling through the air at hundreds of miles per hour. This marvel of modern engineering is designed to withstand incredible forces, but the thought of it encountering a lightning bolt is still daunting. Now picture that metal tube encountering the raw power of a lightning bolt. The flash, the sound, the sudden jolt. It's a scenario that might make even the most seasoned traveler a bit uneasy. The idea of being so close to such a powerful natural event can be unsettling. Yet we routinely board airplanes and soar through the skies, often oblivious to the electrical dramas unfolding above and around us. We trust in the technology and the expertise of the pilots to keep us safe. How do these metal birds, seemingly so vulnerable, survive encounters with one of nature's most potent forces? The answer lies in the design and engineering of modern aircraft. They are built with materials and systems specifically designed to handle lightning strikes, ensuring that passengers remain safe, even in the most turbulent conditions. Engineers have developed sophisticated methods to protect airplanes from lightning, including conductive materials that allow the electrical charge to pass through the aircraft without causing damage. This innovation is a testament to human ingenuity and our ability to adapt to the challenges posed by nature. So the next time you find yourself on a flight during a storm, remember the incredible technology and expertise that keep you safe. Lightning may be a powerful force of nature, but thanks to modern engineering, we can continue to explore the skies with confidence. An airplane soaring through a storm is a sight to behold. The dark clouds, the roaring winds, and the flashes of lightning create a dramatic scene. But what happens when lightning actually strikes a plane? An airplane in flight is essentially a moving conductor in a massive electric field. The metal body of the aircraft acts as a conduit for the electrical energy in the atmosphere. Lightning, always seeking the path of least resistance to the ground, can find these airborne aluminum cylinders quite attractive. When a bolt of lightning strikes, it usually hits the aircraft's nose or wingtips. But here's the remarkable thing. Airplanes are designed to handle lightning strikes. Engineers have developed sophisticated systems to ensure that the electrical charge is safely conducted away from critical components. In fact, it's a fairly common occurrence. Pilots and passengers might not even notice when it happens. Commercial aircraft are struck by lightning on average once or twice a year. This might sound alarming, but it's a testament to the robustness of modern aviation technology. That might sound alarming, but rest assured, these strikes rarely result in catastrophic damage, let alone a crash. How is this possible? The aircraft's design ensures that the electrical current flows around the outside of the plane and dissipates back into the atmosphere. The answer lies in a clever combination of engineering, physics, and a bit of electrical ingenuity. Advanced materials, precise design, and rigorous testing all contribute to making air travel one of the safest modes of transportation, even in the face of nature's fury. One of the key principles protecting airplanes from lightning is the Faraday cage. Named after the brilliant scientist Michael Faraday, this simple yet effective concept forms the foundation of lightning protection for airplanes. Imagine a hollow metal box. If you place an object inside this box and then expose the box to an electric field, the object inside remains untouched. Why? The metal of the box, being a good conductor of electricity, distributes the electrical charge around its outer surface, creating a shield around the hollow interior. This is the essence of the Faraday cage. Now, how does this apply to an airplane? Let's delve into the fascinating world of aviation and see how these principles are put into practice. Think of the airplane's fuselage as our metal box, a Faraday cage soaring through the sky. This metal shell is designed to protect the interior from external electrical forces. When lightning strikes, the electrical current doesn't penetrate the cabin. Instead, it travels along the conductive exterior skin of the plane. This is due to the Faraday cage effect, which ensures that the electricity stays on the outside. Lightning typically enters through an extremity like the nose, a wingtip, or the tail. These points are often the first to encounter the electrical discharge due to their protruding nature. It then courses along the aluminum skin, following the path of least resistance until it finds an exit point, often a static wick or another extremity. The design of the aircraft ensures that the current is directed safely away from critical systems and passengers. These static wicks, small metal filaments extending from the trailing edges of the wings and tail, play a crucial role. They are strategically placed to manage the electrical discharge efficiently. They act as preferential exit points, encouraging the lightning's current to flow off the plane and back into the atmosphere. This controlled exit prevents any potential damage to the aircraft's systems and ensures the safety of everyone on board. So, the next time you're flying through a storm, remember that the aircraft is equipped with these ingenious systems to handle nature's fury. The Faraday cage effect and static wicks work together to keep you safe, allowing the plane to continue its journey unscathed. Protecting the passengers and crew inside the cabin is paramount, but what about the plane's sensitive electronics and internal systems? Just as our bodies rely on a nervous system to function, an aircraft depends on a complex network of electrical wiring and components for navigation, communication, and control. To safeguard these vital systems from lightning-induced surges, engineers employ a multi-layered approach. Wires and cables are shielded and grounded to redirect any stray currents safely to the fuselage. Critical components are often housed in lightning-resistant enclosures, providing an extra layer of protection against electromagnetic interference. Just because a plane is designed to withstand a lightning strike doesn't mean it can simply shrug it off and continue flying as if nothing happened. After a lightning strike, a thorough inspection is crucial. Maintenance crews meticulously examine the aircraft looking for any signs of damage. They focus on entry and exit points, checking for burn marks, structural integrity, and potential damage to the plane's electrical systems. This post-strike inspection is standard procedure and ensures the aircraft's continued airworthiness. It's a testament to the aviation industry's commitment to safety and a key reason why flying remains one of the safest modes of transportation. While it might seem like an extraordinary event, lightning strikes on airplanes are more common than you might think. On average, a commercial airliner in the United States is struck by lightning once every year or two. However, the vast majority of these strikes result in little more than a loud bang and a brief flash. The robust design of aircraft, coupled with rigorous safety protocols, ensures that these encounters rarely escalate into dangerous situations. Think of it this way: you're more likely to be struck by lightning while standing out in the open than you are while flying inside a metal airplane. While airplanes are built to withstand lightning strikes, pilots and air traffic controllers go to great lengths to avoid them altogether. Advanced weather forecasting systems provide real-time data on storm systems, allowing pilots to navigate around areas of intense lightning activity. Air traffic control plays a crucial role, rerouting flights and adjusting flight paths to steer clear of potentially dangerous weather. These proactive measures, combined with the inherent lightning-resistant design of aircraft, make flying remarkably safe, even in stormy conditions. While the Faraday cage principle forms the foundation of an airplane's lightning protection, it's not the only line of defense. Aircraft designers and engineers employ a range of additional safety features to further mitigate the risks associated with lightning strikes. Fuel tanks are designed to be self-sealing, preventing leaks in the unlikely event of a lightning strike puncturing the tank. Lightning protection systems, incorporating surge suppressors and grounding devices, safeguard sensitive electronic equipment from voltage spikes. These comprehensive safety measures, working in concert, ensure that airplanes remain resilient in the face of even the most severe electrical storms. What about the human experience? What happens inside the cabin when lightning strikes an airplane? Passengers might see a bright flash or observe the static wicks glowing, but they're unlikely to feel much, if anything, beyond a slight jolt. The Faraday cage effectively shields the interior of the aircraft from the electrical current, ensuring the safety of everyone on board. Pilots are trained to handle lightning strikes, following established procedures to ensure the continued safe operation of the aircraft. The next time you find yourself on an airplane, gazing out the window at a stormy sky, remember the remarkable engineering and safety measures that make air travel possible. From the Faraday cage that shields the cabin to the rigorous inspection protocols that follow every lightning strike, the aviation industry has gone to extraordinary lengths to ensure your safety. So, sit back, relax, and appreciate the marvels of technology that allow us to soar through the skies, even in the face of nature's most electrifying displays.